Hello, welcome to this video where we look at implicit differentiation, but for a multivariable function. Let's remember what implicit differentiation was for a single variable function. You see, first off, what does implicit function even mean? Here we have y equals x cosine x, a single variable function where you can solve for y and set it equal to some formula on x. That is called an explicitly defined function. The inability to be able to isolate the y changes up the type of function it is. You have x's and y's all commingled together, and you can't untangle that and say y equals. And so therefore, this type of function is an implicitly defined function. It might not even be our actual notion of a function. When we look at the graph of this guy, it doesn't pass the vertical line test. So technically it's not even a function, but still we might want to measure the slope of the tangent line at a particular value of x and y. And we can do that using implicit differentiation. Now, let's go back to when we did it back in Calc 1, and we can improve upon that with our multivariable knowledge now. So back to Calc 1, single variable calculus. Here's what you were instructed to do back then. You were instructed to take the derivative from left to right using the product rule on any term that has both x and y in it. And whenever you encounter the derivative of a term with a y in it, you'd had to multiply by y prime, or some of you might like to use dy dx symbol instead. After that, it becomes algebra. Your job then is to solve for the y prime or the dy dx symbol. So let's just remember what happened back then. Let's take this, go from left to right, product rule on both of these guys because they encounter both, there's a term that has both x and y in it. So when it's time to take the derivative of the left-hand side, you'll have y squared derivative, which is 2y, but there you are taking the derivative of a y term, so you multiply by y prime. Then it's times sine x, then you leave the y squared alone and you take sine x derivative, which is cosine x. So that's the left-hand side's derivative. Then you move to the right-hand side. Minus x squared derivative is minus 2x. Multiply that by cosine y, leave the minus x squared alone, multiply by cosine y's derivative, negative sine of y, but wait, you just took a y derivative, so y prime. I should have color-coded it so you can see the y primes. Our job is to now algebraically solve for the y primes. Let me take this statement and fix up the end of it there, put the terms together. We're talking about 2y y prime sine x, then the y squared cosine x equals to the negative 2x cosine y, and then in that last term there, it's a plus x squared y prime sine of y. Now let's just hit it with algebra. We want to be able to get the terms that have y prime over on the left-hand side, the terms that don't have y prime over on the right-hand side. So subtract over x squared y prime sine y, and subtract over y squared cosine y. Factor out the y prime from the left-hand side, leaving you with the factor of 2y sine x minus x squared sine y, and just divide by it. Now that was a lot of work. There is an easier way, and it's going to lead us to deal with even higher level when we can look at everything being multivariable. So we're going to do the same question with a multivariable approach. Here's how it works. You have this intermingled x and y formula, right? We're going to then create a new function out of it by either setting it equal to a constant if there's a constant floating around, or setting it equal to 0, moving all terms to one side, and call that function capital F. Now here's your job. F is a differentiable function, and so since the function is in the format of f of x y equals 0, then we can like y is a separate function of x that we don't know, because the x and y are commingled together. Y is defined implicitly as a function of x. Call it g of x. So what we can do is think about it as this multivariable function f of x, y as actually a single variable function. It's f of x and g of x. We're not going to actually physically replace y by g of x, so we don't even know what g of x is. We can't find g of x. But the concept is now that capital F, which was first a multivariable function, is now actually a single variable function. And so we can take its derivative, single derivative, prime derivative. We can take df dt, or in this case w, dw dt. Okay. And if you have a function who's equal to 0, then its derivative must also be 0. And so dw dx is equal to 0. But to get dw dx, what we're going to have to do is use the chain rule. Remember the chain rule from the previous video. dw dx is df dx times dx dt, and then del f del y times dy dx. I'm sorry, I said t, I'm sorry. Df dx times dx dx plus df dy times dy dx. That's the chain rule used on it, where the f is multivariable, so it has partial derivatives of x and y. The inside is going to be then, with respect to x, the derivatives, thinking about f as a single variable function. And there's this dx over dx. That's just a 1. So that term gives you a 1. And now we can just do algebra here to solve for dy dx. We'd subtract over the fx term, and then we'd divide by the fy term. And so that was just derivation for the formula. Okay, and there's a higher level to this we'll see when the inside function is multivariable. But anyway, let's do the exact same question we had done in a previous earlier in the video, but let's do it with a multivariable approach. Set the equation equal to 0, call this new function f, take the x partial, take that y partial, and plug them into that formula, the opposite of the x partial divided by the y partial. So here's our same function. We're going to add over the x squared cosine y to set it equal to 0, call that function capital F. We're going to take the x partial, take the y partial, and divide, and take the opposite. That's it. So what is the x partial of this guy? Y squared is a constant, so the x partial starts off as y squared cosine x. And then on the second term, that'll be 2x cosine y. That's the x partial. What about the y partial? Sine x is constant, so the derivative of f with respect to y, its first term is 2y sine x, and then minus x squared cosine y. And then you're done. Divide and take the opposite. It's cleaner, it's not as involved as the other one, and you get to the same point. Y prime or dy dx is equal to that formula. Okay. All right, great. In the next video, we're going to extend this to 3 variables. So we have an x, a y, and a z. So, but it'll basically be reminiscent of exactly what we just did there. This process of creating the multivariable function, set it equal to 0, and taking some partials. But so this video doesn't get too long. Let's go ahead and end it. My name is Nakia. Thank you for watching. Please comment down below, like and subscribe, share. If you want a workbook full of midterm, solutions, please find your way to my webpage, CalcCoach.com, and I'll be happy to help. Thank you for watching. I'll see you in the next video.